Hello students, today I am going to take up the third part of our number system. In the second part, we discussed about recurring and non-recurring numbers and all. In the third part, we are going to discuss about the exercise 1.3 next problems here. What is the third problem? And that also we discussed about the first two problems of 0.6 and 0.47. Now also I just revise those two problems. Okay, what is the third problem here is, first we are taking the first subquotient 0.6. Consider x is equals to 0.6. As on the 6 bar is there, the 6 is repeating number of times. So I have considered the number 0.666. You consider this as equation number 1. Then what is the equation number 1? X is equals to 0.666. As only one digit is remaining in this equation, you have to multiply this equation number 1 by 10. After multiplying, what you are going to get? 10 into x means 10x. 10 into 0.666 means 6.666. This is the equation number 2. What is the next procedure to find out the rational number in this case? Subtracting the equation number 1 from equation number 2. Then as this is the equation number 2, take the left hand side of the equation number 2 first. 10x. What is the left hand side of equation number 1? X. Then the equation becomes 10x minus x. Then right side 6.666 minus 0.666 you are going to get. 10x minus x is how much? 9x. Here only one x is there. So 10 minus 1 is 9x. 6.666 minus 0.66 means answer becomes 6 here. Then x is equals to what? 9 will go to the denominator of the right side term. So x is equals to 6 by 9. 6 and 9 we can cancel by the number 3. So 3 2s are 6, 3 3s are 9, means x is equals to 2 by 3. Then 0.666 means that is equivalent to the rational number 2 by 3. In the same way, we have to solve the second subquotient of this third problem. What is the second subquotient here? Is x equals to 0.47. In this case also, on 7 only the bar is there. On 7 bar is there, means only 7 is repeated number of times. So the number becomes 0.4777. We should not take 474747. Why we should not take 4747 means bar is present only for the 7. So only 7 is repeated number of times. As I am telling only 7 is repeating, only one digit is repeating, you have to multiply that equation by 10. So multiply this equation number 1 by 10. X into 10 means it becomes 10x. 0.477 into 10 means it becomes 4.77. This is the equation number 2. Next step is subtracting equation number 1 from 2. Left side term is here 10x, here x is there means 10x minus x means you are going to get 9x. Right side 4.77 minus 0.477 you have to write that answer is 4.3. Then your equation becomes x is equal to 4.3 divided by 9 it becomes. You want to remove the decimal point in that number means you have to multiply 10 for the both numerator and denominator. Then the number becomes 43 divided by 19. Then 0.477 is equivalent to the rational number 43 by 90. This is about the second subquotient. Next third subquotient here is 0.001 that I have considered here. Consider x is equals to that one. Bar is present on 001. 3 digits you have to repeat. How you have to write that number means 0.001. Again you have to continue 001. Next also it will be continuing 001 like that. As 3 digits are repeated, you have to multiply that equation 1 by 1000. So multiply this equation by 1000. So the equation becomes 1000 into x. Right side 1000 into this term means decimal point will be shifted right side after 3 digits. After 3 digit means 1, 2, 3 means after 1 it will be shifted here. So the number becomes 1.001. See here 1.001. As 001 is continuing right side, you can continue here 001 here. This becomes equation number 2. Then what is the next step? Subtracting equation number 2 from the 2 here. During the subtraction 1000x minus x how much you are going to get? 999 x. In right side 1.001 minus this term is, look at this number. After decimal point, in these two equation right side terms are same. Same terms are there, means answer become 0. Then how to consider? Only before decimal point what is the digit is there. Before the decimal point, here 1 is there, here 0 is there. Then what is the answer? 1 minus 0 is 1. Then your answer becomes 1 here. Then left side 999 is there, right side 1 is there. Then 999 you take to right side. So the number becomes x is equal to 1 by 999. In this case, 0.001 bar is equals to the rational number 1 by 999. This is about the third problem. Next, come to the fourth problem here. What is the fourth problem? Express 0.999 into the form p by q. Nothing but in this problem also we have to convert decimal expansion of a number into the rational number form. Means same procedure has been used in the case of question number 3. Here also you have to use it. Okay. What we have to do is, let's solve the problem here. Look at the question. X is equals to 0.999. Only one digit is repeating. One digit is repeating means you have to multiply by 10. So the equation number 1 becomes 10 into x. Left side, right side, the decimal point will be shifted only one time because I am multiplying equation 1 by 10. After shifting decimal point, the number becomes 9.999. This is equation number 2. Next step is same procedure. Do it. What is the step? 10x minus x we have to do. Number becomes 9x. Right side 9.999. Here 0.999 is there. After decimal point, the digits are same. So answer becomes 0. Before decimal point, in the equation number 2, 9 is there. In equation number 1, 0 is there. So 9 minus 0 means answer is 9. Keep x left side as it is. Whatever 9 is there, you take to right side denominator. So the equation becomes 9 by 9. 9 ones are get cancelled. Then x goes to 1. Here 0.999 is equals to what you got? 1. That only they are asking in the question. You will amazing after seeing the answer, because 0.99 usually 0.999 is there means we will round off that value is equals to 1. No? In the same way here also we got the same rational number answer. Then what you have to write? 0.99 goes on forever. There is no such a big difference between 1 and 0.999. Hence both are equal. These two numbers are equal. This is about that problem. In the continuation, what we should do here is, actually whatever the third problem we discussed, in that we discussed about converting the decimal expansion into a rational number. What is the fifth problem? This is somewhat different. By looking at the denominator, we have to find out how many repeating digits are there. Let's read the question. What is the question? What can be the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 7? I'll just do the problem up to the question mark. In the next slide, I'll continue the problem up to the question mark, whatever is there by 1. What is the question? 1 by 17. In this case, what is the division? It is 17. Division is 17 is that means the number of entries in the repeating block of digits is less than the divisor. Always you have to remember this point. Denominator is 17. Nothing but a division is 17 means in the repeating block, whatever the answer you are going to get, it is less than the divisor means it's 17. Then what is the answer you are going to get for the first sub question? The maximum number of digits in the repeating block is how much? 60. Let's do the second part of the problem. What is the second part of the problem? that is 10. Now also 10 is less than 17 is there. You take one more 0 in the position, then you are going to get 100. Now 100 is greater than 70. You are knowing already the tables. 17 5s are 85. So you write here 100 minus 85 is how much? 15. Later, as you take a decimal point, means you are having the rights to take 1 and 0s in each step. Take one decimal 0 in this step. So the number becomes 150. Then 150 is the rest. 17 8s I have to take 136. What is the remainder? 4. Again you have to take 1 0 in this step. Like that, you just continue the procedure as you are doing the division part. Here, during the continuation, what is the final answer you are going to get? See here, just count it. How many digits are there? 16 digits are there. It means denominator 17 is there, means maximum number of digits are repeated here less than 17. Less than 17 means 16 digits can be repeated. You just count it. How many digits you are going to get? 16 digits you are going to get in the repeating block. This is about this problem. Let's come to the sixth problem. Look at the several examples of a rational number in the form p by q. Means in the question they are not giving any rational numbers for you. You only have to take few rational number is of the form p by q. After taking what you should do, and while taking one condition is that no common factor other than 1. By taking the number, common factor should not be there. And having terminating decimal representation, how should be that number, rational number? After converting into decimal expansion, that answer should be terminating 1. Like that you have to take. After taking what you should find out, see here, can you guess what property q must satisfy? In means, in p by q form, whatever the denominator term is there, no? That q, what property it should satisfy? That property we have to identify by taking the rational number. This is the concept of this problem. Let's solve the problem. I just consider few numbers now. First I tell you the concept. Terminating answer you want means must and should, denominator should be in terms of zeros. It means denominator either 10 or 100 or 1000 or 10,000. Like this only denominator should be there. In terms of powers of 10 should be there. Denominator 10 we are getting means it's easy to write it into the decimal expansion form. You study in lower classes of decimal chapter. 15 by 10 is 1.5. 2 by 10 is 0.2. Means you are getting terminating decimal expansion number. Terminating decimal expansion number you are getting means what is the condition? Denominator should be powers of 10. Denominator we want powers of 10 means what we should do? Let's find out that rule. That rule only the final property of a rule for the denominator q. Let's identify. Okay. What's the first question? 3 by 2. 2 is the to get answer 10 or 100. But greatest lower number. Let's consider that is 10. To get 10, how much we should multiply for 2? That is 5. Then 2 we can take. That time we are going to get 10 here. That time it's easy to find out the terminating answer. Next part. 5 is the can we get any tens otherwise 100 number in the denominator by multiplying with some other number? Yes. 5 2s are 10 we will get. So you know that's what denominator is what? 5. Next 8 I consider. 8 125 is 1000. That's okay. But look at the 8. Whether 8 is a power of 2? Yes. Denominator 8 is equals to what? 2 cube. Like that 125. 125 x is 1000. Later it's you will get a terminating decimal expansion. That's right. But what about 125? 125 is a power of 5. That is very important. Like that, we just continue the procedure. Then what is the concept you got? Denominator either the power of 2 or otherwise the power of 5. It means what property the Q should satisfy now? It satisfies the powers of 2 are powers of 5 here, are of both here. This is the main answer for this problem. Next, 7th problem. Write 3 numbers. How many numbers you have to write? 3 numbers whose decimal expansion non-terminating, non-recurring. You have understood easily. Non-terminating, non-recurring is what? This is irrational number. Irrational number means the number which is of the form square root form. Otherwise, the number which cannot be written in the form of p by q. Which number we cannot be written in the form of p by q? That is root 2, root 3, root 5. Don't consider root 4 because 4 is perfect square. If you take square root 4, that is equivalent to the value 2. That 2 is a rational number. That doesn't become irrational number. According to the question, we have to find out irrational number. It means non-terminating, non-repeating, otherwise non-recurring. So you can write root 2, root 3, root 5. For other example also you can write its equivalent value also you have to write. Root 2 means 1.414213, 562, 1.73205, 0808 for the root 3. Here it is not terminating, dot should be written. This is very important. You can write some other examples also. Next, come to the 8th problem. Find 3 different irrational numbers. Then irrational number means you have to think about it in decimal expansion, how it should be. It is of the form not terminating, non-repeating. Okay. The rational, between the rational numbers 5 by 7 and 9 by 11. To find out the irrational number between 5 by 7 and 9 by 11, first you have to convert these two into decimal expansion form. Later in between whatever the number comes, that you have to write. First let us convert it. 5 by 7. In 5 by 7, 7 is the division, 5 is the dividend. So write here 7, write here 5. You are already knowing the division process. As 5 is smaller than 7, you are taking the decimal point in the quotient place. So the number becomes 15, then 7 sevens are 49, then 50 minus 49 is 1. Later you are having the right step, 1 0 in each step, as you take a decimal point in the quotient. So the number becomes 10. Then 7 ones are 7 is, remainder becomes 3. Like that you just go on continue. Like that you continue for 9 by 11 also. After doing division, what you should do? Main point, look at the quotient answer. After decimal point, you just concentrate mainly on the two digits. Look at the first number, 0.71 is there, 71. This is the main point you have to identify. Here what is that? 0.81 is that. Means you have to write irrational number between 0.71 and 0.81. This is the main point you have to identify by considering the question here. 0.7, after that what is the number comes? Less than 81. 0.72 you can take, 73 you can take. That's your wish. I have considered here 0.75 I have considered. In what way you have to write irrational number? That is also very important. Irrational number means non-terminating, non-repeating. It should not repeat here. Then what is the easy way to write this? You have to follow. It is easier. You can write any number here. 750 you write. Later you write 7500 you write. Afterwards you go on writing 75000, 7540, like that you just continue. That is a irrational number. Easy way to write. You just remember this concept. After 75 you can take 76. 7670, 76700. You can write 760, 7600, 76000 also. That's your wish. But here I consider some different example. That's your wish. You can take any number. See here one more number I consider 780800, 7800, 7800 like that. Means how you have to write that the number should not repeat. That fashion you write. Don't write 78, 78, 78 like that. Other than that, you are writing any other fraction means that's correct only for irrational number. That is about which problem? 8th problem. Let's come to the last problem of this exercise. What is the last problem? Classify the following numbers as rational or irrational. Look at the first question, square root 23. Well, consider this. One important point you have to identify here is square root of perfect square numbers, it should not be there. If it is perfect square number is there inside the square root means that is not a irrational number, that is a rational number. Two problems are there like that. By this you will clarify the concept. Look at this. First question is square root 23. Whether 23 is a perfect square? No, it is not a perfect square. That's what square root 23 is. Which number? Irrational number. What is the next problem? 225. Square root 225. 225 is perfect square. 15 square is how much? 225. That's what is the answer you are going to get. Square root 225 is rational number. Next, what is the third problem? 0.3796. 0.3796. It is terminating number. Terminating decimal expansion. Terminating decimal expansion means it is a rational number. Then what is the next problem? 7.478, 478 and non-terminating. Means this is non-terminating repeating number. Non-terminating repeating number means this is rational number. Here I have it. What is the next one? 1.101, 100, 100, 140. Does any digits are repeating? No. It is not terminating. Okay. But none of the digits are repeated here. None of the digits are repeated means it is non-terminating, non-repeating number. Non-terminating, non-repeating means this is what? Irrational number. This is about the last problem of the 1.3 exercise. In this exercise, we discussed about the hard types of problems under the decimal expansion of a real numbers here. Then in the next part, we will discuss about the other topics. This is about the part.